Good morning, everyone. So I'm Luca Sanguinetti from the University of Pisa, and I'm here as the project coordinator of the Times project, which is about terahertz industrial mesh networks, smart sensing and propagation environments. So let me thank you for for giving me the opportunity to present, the major aspects of the project. So a short overview of the project. So we are 10 partners in the project. We are from 5 European countries, and we have here CNIT. I'm also, as you as you see, I'm also affiliated with CNIT in Italy. And then we have, 3 academic partners, 2 research institutes, 3 big industries, and then we have an SME in total, which is about the design and development of antennas and intelligent reconfigurable surfaces. The project is about, as you can see from the title, is about terahertz communications to smart propagation environments, and the verticals that we are targeting are basically the industry 4.0, industry 5.0, but then we have also interest in healthcare and automotive applications. So the long-term vision of the project is about designing a smart radio ecosystem in a complex scenario by offering the same performance as wired networks. And to achieve this long-term vision, we are making use of 3 different pillars. One is the terahertz communication and networks pillar. Then we want to develop intelligent mesh protocol, intelligent mesh networks operating at those frequencies and taking advantage of smart propagation environments, which means that we're going to take advantage of the so-called reconfigurable intelligent surfaces to model the propagation environment in a way to facilitate the terahertz communication links. And then we are also going to exploit the integrated communication and sensing technology. In this picture here, there is a possible application scenario in the context, in the industrial context, where we have all the 3 different pillars all together. Trying to achieve this long-term vision. As you can see, we have static and mobile devices communicating through single links, multiple links, taking advantage of reflection, taking advantage of large intelligent surfaces, which are more active arrays compared to the passive nature of the intelligent reflecting surfaces. In terms of innovations, we are targeting, first of all, to identify the specific use cases for this kind of long-term vision. We want to define also the key performance indicators for a system which is complex in the sense that is made of different devices of different nature, different requirements, different mobility and characteristics, and so forth. Then in the context of terahertz communications, we want to, first of all, develop channel models based on channel measurements for inter and intra-device machine communications. The electromagnetic exposure characterization. We want to provide technological solution for the ultramassive MIMO technology, fast beamforming, and the electromagnetic processing of signals. So signal processing operating directly at the electromagnetic level. And then we want also to develop integrated radio frequency front ends for the terahertz frequency bands. In the context of intelligent mesh networking in smart propagation environments, the idea here is to develop protocols for operating in a network which has a mesh topology with active and passive devices. And when I say passive, I mean the intelligent reflecting surfaces, enabling the communication over multiple links and through the use of these configurable surfaces. In the context of integrated sensing communications, we want to take advantage of the functionality of the reconfigurable intelligent surfaces to enable the see around of the corner functionality of these devices, as well as we want to increase the localization functionalities of the system by taking advantage of the near field third propagation conditions. And the major idea here will be to test and demonstrate developed technologies in two different proof of concepts, which will be realized in two different pilot plants of our partners. The way the project will run in the next 3 years, first of all, we have a work package 2, which is about the scenarios and requirements and key performance indicators. The outputs of this work package will be, first of all, provided to the work package 3, which is about channel modeling and channel measurements. And then we have 2 work packages about the development of solutions for TEDx mesh networks assisted by integrated sensing communications and the smart propagation environments. And then we have a work package on the hardware components, TEDx hardware components. The 3 work packages are very much integrated, connected during the 3 years of the project, and the outputs will be used to develop the proof of concept and demonstration at the end of the project. And of course, the outcome of the proof of concept will be the input for the work package to just in the case we need to refine the different scenarios, requirements, and key performance indicators. In terms of expertise, I think we have a very good consortium to take to tackle the challenges that we are targeting in the project. As you can see, we have expertise in system architecture and requirement, circuits, components, and packaging, antennas, intelligent reflecting surfaces, channel measurements and modeling, communication sensing networks, and then we have a expertise in the demonstration of different of technologies. Just to give you an idea, 4 of the 10 partners of the project have recently successfully demonstrated the first, 2 by 20 gigabit bidirectional 300 gigahertz link over 160 meters in the TOR project, which is a joint European-Japanese project. So in the project, we're going to take advantage of this, expertise to extend the technologies to the more complicated scenario that we envision in the TIMES project. Just let me say a few words about the proof of concepts. So the idea is to have 2 different proof of concepts, one in the Virex pilot plant, which is an advanced production line where we can test different technologies for industrial processes. We have different thematic areas about additive manufacturing. We have robots. We have mobile and fixed robots. And then we have also server for big data analysis, and we can also take advantage of a 5G private network operating at 27 gigahertz, which can be used to compare the performance that we are going to achieve with the technology solutions that will be developed in the project. And the other pilot plant is provided by another partner of the project, which is Aetna. Aetna is a very big company in the context in the automated packaging context, and they are going to provide us the tech lab, which can be used break. I mean, to remove the wire connections they have in the tech lab to, I mean, with the wireless connections that we're going to develop in the project. Regarding the standardization activities, let me say a few words. So we are planning to contribute in terms of industrial simulation scenarios and KPIs. We're planning to contribute with turrets channel measurements and modeling in the industrial scenarios, as well as with technology enablers for the industrial turrets communications and networks. The potential bodies that can be interested in our outputs will be the ETSI industry specification group for tethers. Let me say you that 5 funding members are part of the consortium, and in particular, TBS is the chair of the industry standardization group. Then we're planning to contribute to the industry standard specification group for reconfigurable intelligent surfaces, cost interact, and 16G, where we have 4 funding members of 16G are part of the consortium of the project. I think I'm done. Maybe I have time, and this and just to let you know that if you want to follow us, you can check the website and then all the different social media that are already active.
Thank you very much, Luca.